Welcome students. Now in the last videos we have seen about cubic systems. Now we will see some more cubic structures. Okay. We have studied about simple cubic system, BCC, FCC and HCP structures and their packing fractions, what you call the coordination numbers, etc. They are all one atom basis structures. Okay, means at one lattice point, I'll put only one atom. Okay, if a cube is like this, if I say, right, BCC, body centered cubic structure means I'll put 8 lattice points on the 8 corners and one additional lattice point at the body center. This is what BCC we have seen. What are the coordination numbers, etc. All we have covered in our previous lectures. Okay. Now at each lattice point, I'll be putting only one atom here. Okay, means one lattice point is containing only one atom. So it is a one atom basis structures what we have seen. If I put copper atoms here, right, I'll get copper crystal. If I put silver atoms, I'll get silver crystal. If I put what you call iron atoms, I'll get iron crystal, like that. Okay. Now what happens if I put what you call more than one atom at each lattice point? Okay, means I can put what you call two atoms also at each lattice point. They are called two atom basis structures. Okay. How do we analyze those two atom basis structures? Now we are going to see. Okay. Right now, you take first example, the first what you call the two atom basis structure is simplest to understand is what is known as cesium chloride structures. Okay, CsCl, CsCl we call. Now here the basic structure is a cube like this. Okay, right, there will be 8 Cs plus ions on the 8 corners, 8 Cs plus ions on the 8 corners. These red dots are all locations of Cs plus ions. Okay, and one additional lattice point will present at the body center, which is nothing but Cl minus ion. Okay, Cl minus means on the 8 lattice points we have Cs plus ions and at the body center we have one Cl minus ion. Apparently this say if you ask anybody, right, we'll say that it is body centered cubic structure because we are finding one body centered lattice point. Okay, right, but now, right, I'll try to analyze. So how do we what you call characterize CsCl means its lattice constant A equal to, right, 4.11 angstroms. Okay, means side of the cube is 4.11 angstroms. There are 8 Cs plus ions on the 8 corners and 1 Cl minus ion at the body center, or otherwise also because it's a 3-dimensional structure. Because I have cut the unit cell from these points, I got Cs plus ions on the 8 corners and Cl minus ion at the body center. If I ask you to cut the crystal, so the lattice, okay, you'll start from here. If you start from here and go like this, okay, so your structure will be somewhat like this, right? You will be getting Cl minus ions on the 8 corners and one Cs plus ion will come at the body center. So it makes no difference whether you consider Cs plus on the corners and Cl minus at the body center or vice versa. Okay. In general, what do we say? If there are 8 Cs plus ions, in brackets Cl minus ions on the 8 corners, one Cl minus, if Cs plus are on the corner, Cl minus will be at the body center. If Cl minus ions are on the corner, right, Cs plus will be at the body center. It depends on the way you cut the unit cell or the way you consider the unit cell. Okay, right. Now lattice constant is A equal to 4.11 angstroms. Now I want to simplify the structure further. Instead of seeing this crystal as consisting of Cs plus ions and Cl minus ions separately, I will take this Cs plus and Cl minus as one unit. Okay, so I'll consider this Cs plus ion which is on the corner and the Cl minus ion at the body center as my lattice point, one unit. Okay, and I'll try to simplify or redraw the picture like this. I'll try to redraw the picture like this. Now what do I do? Okay, I'll take one cubic system. Like this. Okay. At each lattice point, simply I'll put one lattice. At each corner, I'll put one lattice point. That's all. Okay. So what type of structure is this? Earlier it was looking like BCC. Now it got simplified to simple cubic because only on the corners lattice points are present, nowhere else, no lattice point at the body center. Then how do I develop this into crystal? Means, right, at each lattice point, I'll put one CS plus and one Cl minus like this. Okay, this is CS plus, so I'll put one CS plus here and Cl minus here. Okay, see at every point, here CS plus and at distance Cl minus. Here one CS plus and at this distance Cl minus. Here one CS plus and at this distance Cl minus like this. Everywhere I'll put like this, such that what happens, I'll get the earlier, right, 8 corners, 8 CS plus ions and 1 Cl minus ion at the body center. Means the crystal, in the actual crystal, CS plus ions and Cl minus ions are on the corners and at the body centers also. But I am simplifying the crystal structure into simple cubic system. So CsCl belongs to simple cubic lattice type. Simple cubic lattice type with its basis containing at each lattice point how many ions have to put? 2 ions have to put. One is CS plus and one Cl minus ion have to put. Okay, right? Means what is the structure of CsCl? Now I don't have to have, I should not have any confusion whether it is simple cubic or I'll say simply simple cubic. Why? I'll simply keep on putting, right, lattice points like this, just like in simple cubic system. Okay, simply lattice points will be arranged like this. If somebody is arranging lattice points like this, it is simple cubic system only. Okay, now what is now develop the actual CsCl crystal. Means what do? Right, one CS plus I'll put here, one Cl minus here, one CS plus here, one Cl minus here. Okay, one CS plus here, one Cl minus here, one CS plus here and one Cl minus here. Okay, if I consider this structure, CS plus ions will be on the corners and Cl minus ions will be at the body center. What we have drawn in the earliest case, right, will come, that picture will come here. Okay, so a crystallographer simplifies a complicated structure, right, by increasing the number of atoms in the basis. Okay, so here each lattice point is not containing one atom or one ion. Remember, each lattice point is containing 2 atoms. One is CS plus and one Cl minus. Therefore, right, how do we characterize CsCl? CsCl belongs to simple cubic lattice with its basis containing 2 ions. Okay, 2 atoms or 2 ions. Right, one is CS plus and other is Cl minus. Okay. In the body, in the actual crystal, at the one which is at the body center, what will be its coordinates? Tell me. If I take this as my origin, okay, this as my origin 0, 0, 0, the coordinates of the body center will be, how to reach the body center from the origin? I will travel a by 2 distance along x-axis. I will travel a by 2 distance along y-axis. I will travel a by 2 distance along z-axis. Means the coordinates of Cl minus will be a by 2, a by 2, a by 2 and a by 2. So, right now I'll say, somebody asked me to describe simple cubic CsCl system. Is it belongs to simple cubic lattice with its basis containing 2 atoms. Okay, one is CS plus and another one is Cl minus. If CS plus is at the origin 0, 0, 0, Cl minus will be at a by 2, a by 2, a by 2. Okay, so, right, what is the structure of CsCl? Right, the lattice structure of CsCl is simple cubic. Okay, how am I reducing it to simple cubic? Though it is apparently BCC, right, I am reducing it to simple cubic. How? By considering 2 atoms in my basis. One is CS plus and another one is Cl minus. If one CS plus is at the origin 0, 0, 0, the other the Cl minus will be at a by 2, a by 2, a by 2. Okay, this is how we analyze 2 atom basis structures. Okay, one more most important and most common example is what you call NaCl, sodium chloride, common salt, we all know. Okay, common salt, we all know, right? Next 2 atom basis structure which we are going to consider. If you look at this NaCl structure, it looks highly complicated. Okay, though we call it as common salt, right? Once anybody sees this structure, it looks like most uncommon salt. Okay, right? We take common salt or salt very lightly. Okay, but structure, if you look at the structure, you will develop respect for even salt also. Okay, it looks highly complicated because you will find atoms at the corners, atoms at the body center, atoms at the face center, everywhere atoms will be present. So how do you simplify its cubic, its structure? Means we'll see now. Okay, right? Now, this is how we draw a unit cell of NaCl. Okay, just like you take a big cube. Okay, cut it into 8 pieces, 8 equal pieces. Means how do you cut it into 8 equal? One big cube you imagine. Okay, this crystal structure you need some little bit of imagination. Okay, you should close your eyes and try to visualize the structure. Right? You take one big cube. First, cut it into 2 equal parts, half vertically like this. And again, like this also vertically downwards. Okay, right? Vertically downwards. One is like this, it becomes 2 parts. When you cut it like this, it becomes 4 parts. Now what do you do? Third time, you cut it horizontally like this, exactly from the midpoint. Okay, such that it will become 8 parts. That's what I have done here. The structure is, right, one big cube has been divided into 8 smaller cubes. 1, 2, 3, 4, 5, 6, 7, 8. Now, where do I place atoms here? Okay, where do I place atoms here? It contains both Na plus ions and Cl minus ions. Okay, on the what you call 8 corners and the face centers, you first arrange Na plus ions. Means Na plus ions, you arrange them in face centric structure like this. Okay, right? Means face centric structure means what? We'll have 8 atoms on the 8 corners and 1 atom at the center of each face. Means here what called the corner 8 corner atoms have come, one face centric atom, right face centric atom, bottom face centric atom, and bottom face corners also, right, are what you call fixed with NaCl. Okay, right? Now left face, all 4 corners have already come, left face centric atom. Front face also 4 corners have been covered. This is front face centric atom. Back face also, right, corner atoms have been covered. So back face centric atom like this. So this is now Na plus ions arranged on the face center, in face centric manner in a given cube. Okay, now wherever the lines are actually joining, actually intersecting, right, put Cl minus ions. Okay, wherever lines are actually intersecting means, look at this. Okay, right? Now, do you expect two lines to actually intersect here? No, it's a 3-dimensional figure drawn on a 2-dimensional board. So it appears as if it is, they are cutting here, but they are intersecting here. But there is no intersection here because that is in the back, that is in another plane, this line is another plane. Here also, there is no actual contact between these 2 lines. But here, the lines are actually having contact here. So I'll put Cl minus here. Okay, here we have Na plus. Okay, these red dots are all Na plus ions. Red dots are all Na plus ions. Okay, Cl minus I indicate with this blue color dots. Okay, right? Now, it is like this, Cl minus here. Here also, actually there is no contact between the lines here. If you closely observe, you can draw this on your notebook, and you can see there is no contact or no intersection of lines here. But lines are meeting here, intersection of lines is occurring here. So I'll put one Cl minus ion here. Again, here also the lines are actually, right, intersecting each other. Okay, I'll put one Cl minus ion. Here also the lines are actually intersecting. So I'll put one Cl minus ion here. There is no contact between lines here or here or here or here. No. Okay, it is because 3-dimensional figure is being shown on a 2D board, the line appearing like this. Okay, right, now we have Cl minus ion. Similarly, now in the bottom plane, put Cl minus ions on the face centric points like this at the face centric. Okay, on the 8 corners and at this. Again, just wherever you have put Cl minus ions at 4 places, just in the plane below, you replace you put Cl minus ions here. Means one Cl minus ion comes here, one Cl minus ion comes here, right, here and here. Right, so these red cross marks are all Na plus ions. Okay, blue dots are all Cl minus ions. This is our, right, unit cell of common salt or sodium chloride. Okay, if anybody who looks at this structure, we will no longer call it as common salt. It is the most uncommon salt. Okay, right, now this is our actual NaCl structure. Right, Na plus and Cl minus ions will be arranged like this. Lattice constant A is about, right, A equal to some 5.68 angstroms. Lattice constant A is about 5.68 angstroms. Now, which type of crystal structure it belongs to? Can I call it as simple cubic or BCC or FCC or HCP? No, atoms are present everywhere. No, body centric atoms are there, face centric atoms are there, everywhere atoms are present. Okay, this is the smallest representative unit of NaCl. Okay, how do I further simplify? This looks like very complicated one. Okay, right? How do I simplify this? Means I'll say what? NaCl belongs to, though this is not apparently looking like FCC, right? Apparently looking like FCC, I'll say that NaCl belongs to FCC lattice type. NaCl belongs to FCC lattice structure with its basis containing, containing 2 atoms. or ions, whatever it is. Okay, two atoms. One is Na plus and Cl minus. Na plus and Cl minus. Okay, right? I can simplify this. I won't draw this complicated figure. If somebody asks me to draw the lattice of NaCl means, I'll simply draw like this. I'm showing only the upper face. I'm showing only the upper face, means only this face. Whatever happens in this face will happen in the, what you call the planes. Only the upper plane, upper face only I'm considering. Okay, right? Will happen in the bottom faces also. Okay, Na plus here. What do? I'll put lattice points. I'll put lattice points according to FCC. FCC means what should I do? I have to put on four lattice points on the four corners and one lattice point at the face center. This is face centric arrangement in the upper face of NaCl. Now here each lattice point will not contain one atom or one ion. It will contain two atoms, one Na plus and one Cl minus. Now I take this Na plus and Cl minus configuration as my lattice point or as my basis. So this is one Na plus Cl minus. This is one Na plus Cl minus. Okay, this is another Na plus Cl minus. This is another Na plus Cl minus. One Na plus ion will be at the adjacent what you call unit cell. Similarly, right here, this one is Na plus is here. Its Cl minus will go to the next unit cell. Okay. So here, this is structure. What type of structure this looks like? This looks like what is known as face centric cubic structure. Okay, then this is not NaCl. Okay, this is only NaCl lattice. Now you will ask me, sir, develop NaCl structure from this. Develop NaCl structure means what do I do? At each lattice point, I will put one Na plus and Cl minus separated by distance of A by 2. Separated by distance of A by 2 means at this point, what do? I'll put one Na plus and one Cl minus like this. Separated by distance of A by 2 means Na plus and Cl minus I'll put. Similarly here also I'll put one Na plus and at A by 2 distance here I'll put my Cl minus. Similarly here I'll put Na plus and at A by 2 distance from here I'll put one Cl minus. Similarly here I'll put one Na plus and at A by 2 distance I'll put Cl minus. Here also Na plus and one Cl minus. Here also, right, I'll put one Na plus and Cl minus here. Like this. Okay, this is my lattice point. This is also 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 my lattice point. Means I have arranged lattice points according to FCC. At each lattice point, I am putting what you call two atoms Na plus and Cl minus separated by distance of A by 2. Okay, so I'll call NaCl as what in a simplified way. I'll say that NaCl belongs to FCC lattice with its basis containing two atoms. What are those two atoms? Na plus and Cl minus. How should I put them? How do I put them? Separated by a distance of A by 2 in the straight line. Okay, right? In a linear fashion, separated by what you call a distance of A by 2 in a linear fashion, right? Na plus Cl minus Na plus. If you look at this, it is nothing but our top face of this NaCl only. Similarly, the bottom face, this one also can be replaced like that only. So NaCl belongs to FCC lattice structure with its basis containing two atoms, one Na plus and one Cl minus. Okay, if one Na plus is at the origin 0, 0, 0. Okay, if one Na plus is at the origin 0, 0, 0, right, nearest to Cl minus, either this or nearest to Cl minus, you can consider the basis like this or like this or like this also, no problem. But you cannot take this as basis because this is at a larger distance. Okay, this is at A by 2 distance, this is also at A by 2 distance, this is also at A by 2 distance. Okay, so if one Na plus is at the origin 0, 0, 0, the other Cl minus, the Cl minus ion will be at A by 2, 0, 0. A by 2, 0, 0. Okay, right? Now, it can, if you consider this as your basis, you can consider this or this or this, anything. Okay, what happens here also? If one Na plus is at the origin 0, 0, 0, nearest to Cl minus is at 0, A by 2, 0, because this is along y-axis. Okay, this, what are the coordinates of this Cl minus ion? It is 0, 0, A by 2. Whatever it is, 1 A by 2 and 2 zeros, remember like that. If, right, NaCl contains, right, basis of NaCl contains two ions, one is Na plus and other one is Cl minus. If Na plus is at origin 0, 0, 0, Cl minus will be at 1 A by 2, 2 zeros. Okay, wherever you want to put that A by 2, you can put. Okay, consider this as your basis or this or this. Okay, so these are all two atom basis structures. One is CsCl and other one is NaCl. if you look at NaCl structure as it is, okay, you will find atoms or ions everywhere. You will find atoms or ions everywhere. For one type of atoms, okay, for one type of atoms, it appears like what you call FCC. So what I am doing is I am simplifying the structure by taking Na plus and Cl minus as my unit. Na plus and Cl minus as my unit, and I'll simplify the picture into FCC structure. At each lattice point, only thing I have to do is what? I have to replace each lattice point with two atoms, right? One is Na plus and one is Cl minus, linearly separated by distance of A by 2. Okay, this is the structure of NaCl, the most common thing. Okay, wherever you go, right, whichever it is, NaCl means structure will be like this only. Okay, right? So these are two simple, what you call, two atom basic structures. And one more very important from exam point of view also, it is known as a diamond structure. Okay, that we'll cover in the next video. Thank you.